Hello and welcome back to Crystallography for everyone. In this video, we are going to look at some Miller index examples. I'm going to start off with another example similar to the last video. I'll redefine my axes. This is the x direction, this is the y direction, and this is the z direction. And I've added another arrow here for the minus y direction. I will draw another plane. If you recall, requires 3 points in space. So I think I will start here, change colors. I'll start here at minus 3 in the y direction. Then I will go plus 2 in the x direction and plus 1 in the z direction. And I will draw in this plane. And again, I will shade because I think that this really helps you to visualize the plane. I will write down the same chart as before, where we have the x, y, and z coordinates. We have the intercepts, the reciprocals, which I will abbreviate, and the Miller index. The intercept in the x direction is x equals 2. In the y direction, we have y equals minus 3. And in the z direction, we have z equals 1. If we take the reciprocals of these values, we have 1 over 2 minus 1 over 3 and 1. Reciprocal of 1 is simply 1. And then to clear these fractions again, we can multiply by 6 to get 3 minus 2 and 6. Since this is a Miller index specifying this crystal plane, I will write out the index in parentheses. So we have 3, 2, and 6. The convention for handling minus signs is to put a bar over the 2. So we would call this plane the 3, 2 bar, 6 plane in parentheses. I'll do another example for, oops, I should probably keep that. Erase these, but try to keep my chart around. This time I will go to z equals 4, change colors, z equals 4, x equals 2, and y equals 1. And I will draw in this plane and shade it. If we go back to our chart, we have x equals 2, change colors, drop my pen. We have x equals 2, y equals 1, z equals 4. We can take reciprocals. And then to clear, this time, to clear our fractions out, we can multiply by 4. And this will give us 2, 4, 1. So this plane is the 2, 4, 1 plane in parentheses to denote the Miller index. I will do one more example in this video, and this time I am going to restrict us to a cubic unit cell. So I've previously drawn in this cell over our grid here. I'm going to redefine the axes a little bit. So each unit on the axes will now be 1/4. So the edges of our cube here are going to be all 1, 1, and 1. This is standard for dealing with a single unit cell to define the edges as 1. We would do the same thing for a rectangular cell or a rhombohedral cell or a triclinic cell. And we can look at the crystal planes restricted to inside just this one cell. The first example that I'll go through is going to let us get around calling faces the front face or the top face or the left or right, which is very inefficient as we've previously seen. So I will define this front face of the crystal. Hopefully this is going to be one of the last times I call it the front face. And I will redraw my little chart. So we have this plane here, and we can clearly see that it intersects at x equals 1. But it is parallel to the y and z axes. You can imagine this plane extending off in the minus and plus y, z directions. And you can imagine that it's never going to actually intersect the y or z axes. So we have to kind of cheat to account for this. And the convention when we're working with Miller indices is to call the intercept for a plane that does not cross the y or z axes, or does not cross a particular axis in our system. We say that it intercepts at infinity. So we have 1 in the x axes, infinity in the y and z axes. And we can just repeat our procedure as before. So we will take the reciprocals. We get 1, and then 1 over infinity and 1 over infinity. You might be familiar from algebra that 1 over infinity, or 1 over a large number, large, is approximately 0. So we can call these two guys 0. So our reciprocal values are 1, 0, and 0. Since these are not fractions, I can directly write down my Miller index from the reciprocals of the intercepts. So this plane is the 1, 0, 0 plane. From now on, we will not have to call this the front face of the crystal. We have a fairly universal way of describing this plane, this face of the crystal. It is the 100 plane, or the 100 face, you'll hear people say. And this is a really good way of describing at different parts of the unit cell to other people. In the next video, we will look at some more examples working within the unit cell at some more complicated crystal planes. I hope to see you there.